Welcome back for the second installment of the AP ECE Chemistry Chapter 13 Acids and Bases problem set. Let's pick up with problem number 27. For problem number 27, you're asked to find the OH concentration, H plus concentration, pH, and POH for a solution that is 0.27 molar SrOH2. Now, the fact there's 2 hydroxide per 1 formula unit of strontium hydroxide means that you need to consider separately and differently what the concentration of the hydroxide actually is. So it's going to end up being doubled. With a quick dimensional analysis, you can find the concentration of the hydroxide as 0.54 molar OH. So to find POH, you do the negative log of the OH concentration here. The negative log of the 0.54 gets you a POH of 0.27. That's very, very basic. pH is found easily by noting that pH plus POH is equal to 14, so we can find the pH is 13.73. It might be more recognizable to you as very, very basic from that. And since Kw is equal to the H plus concentration times the OH concentration, and that's also equal to 1.0 times 10 to the negative 14th, the equilibrium constant for water, you can substitute in the concentration for hydroxide and then find out that the hydrogen ion concentration is very small, 1.85 times 10 to the negative 14th. For problem 27, there's also a part B where you're still finding the H plus concentration, OH concentration, pH, and POH. You're given a mass of KOH. You need to use some dimensional analysis, and the volume that you're given to find what the concentration of OH is. It's 0.0970 molar OH. Negative log down here of that concentration gets you a POH of 1.01, very basic as well. You can find the pH from 14 minus the POH. The pH is 12.99, and then now that you know the pH, you can do the reverse operation. If pH is the negative log of H plus concentration, then the H plus concentration is 10 raised to the negative pH. 10 raised to the negative 12.99 is 1.02 times 10 to the negative 13th molar. So that's the concentration of the hydrogen ion. Let's check out problem number 31. In problem number 31, you're asked to find the pH of a solution that has 13 grams of NaOH and 795 milliliters of 0.2 molar SrOH2. So now it's sort of like you combined what has happened in the previous problem, problem 27. So the first thing is to find the number of moles, N of OH, from both of the sources. So you convert your 13 grams of NaOH into a number of moles of OH, and you consider your volume, 0.795 liters of strontium hydroxide, and its concentration, 0.2 molar, and the fact that there's 2 moles of OH for every 1 mole of strontium hydroxide, you get another 0.318 moles of OH minus. Summing them, you get a total number of moles of hydroxide of 0.643 moles of hydroxide. Divide that by the overall volume, assuming that the adding of the 13 grams of NaOH didn't increase the volume, and you find your overall concentration is 0.809 molar OH. Find the POH by doing the negative log of that OH concentration, and the POH is 0.092. Then do 14 minus that, and you can find that the pH is 13.91. Let's check out problem number 37. In problem number 37, you're asked to consider a couple of acids with given pKa values of 3.7, 9.2, 7.4, and 1.6, and you're asked to arrange them in terms of decreasing acid strength. So D, having the lowest pKa value, should be the strongest acid. A, the next lowest, should be the next strongest acid. C, the next lowest at 7.4, should be the next strongest acid, and the weakest acid is B with the lowest pKa value. So which one has the largest Ka? It's actually D with the largest Ka.